Namaste students, I am JV Dr. Aziz Umad Khan from Department of Food and Biotechnology, Faculty of Agriculture and Veteran Science, Jyoti Vidyapith Women's University, Jaipur. Today I am going to discuss about the topic crystallization. Crystallization is the final step of the downstream processing. The last stage. The first was separation of the insoluble organic inorganic compounds. Second one was purification, isolation of the pure compound. Third was purification of the pure compound, and the fourth is product polishing, in which the product polishing include uh, finalization of the product. So crystallization is also a type of the finalization of the product before sending it to the market. So what is the definition of the crystallization? Crystallization is the process of formation of the solid crystals. Okay? It is a process of the formation of the solid crystals precipitating from a solution, melt, or rarely deposited directly from a gas. Crystallization is also a chemical solid liquid separation technique in which mass transfer of the solute from liquid solution to a pure solid is conducted. What is crystallization? Is a chemical solid separation technique in which mass transfer of the solute from liquid solution is conducted to form a pure solid. That is the crystallization method. Crystallization is important as an industrial process. It is used in the industries because uh, of because there are number of materials that are present and they can be marketed in the form of the crystals, and there is a necessity to form crystals because the compounds, the products are not stable in their natural forms. So for making them in a stable form, we can prepare them into the crystals. Crystallization may be carried out from a vapor, from a melt, or from a solution. Okay? Anything can be crystallized, a gas, a liquid, or a solid can be crystallized into any form. And more than 80% of the substances used in the pharmaceutical, fine chemicals, agrochemicals, food, cosmetics are isolated in solid forms by the process of the crystallization. And crystallization is in general the last chemical reaction step in the production of ingredients. In which if we are making any product by downstream processing, in which we first prepare the product, then we purify the product. Okay, by removal of the fibers, insoluble compounds, large compounds. Then we isolate pure products. Then we purify the pure products. After that, the product which was purified, then we made it in the crystallized form so that it may be stable. Crystallization is also chemical solid separation in which mass transfer of solute from liquid solution to a pure solid crystals phase occurs. It is extensive uses in the fact that the single location is both a separation of purification process whereby solid crystalline product can be isolated in high purity. A solid crystalline product can be isolated with high purity, relatively low capital and operating cost. So this is the basic fundamental of crystallization. What are the crystals? What are the crystals? Uh, a crystal may be defined as a solid which is composed of the atoms. Okay, a crystal may be defined as a solid which is composed of the atoms arranged in an orderly, repetitive array. Means the atoms which are present in a solid material they are arranged by the crystallization methods. Okay. The crystals are grown in many shapes which are dependent on downstream processing and final product requirement. Different sensor shapes can be achieved. And it depends on the product, which product we want, which what is the basic of this particular product, and on that basis we can design different shapes of a particular product. Crystal shapes can include cubic, cubic, tetragonal, orthochromic, hexagonal, monoclinic, triclinic, and trigonal. Which shapes? Cubic, tetragonal, orthochromic, hexagonal, monoclinic, triclinic, and trigonal. So these are the shapes which can be used. Yeah, in order to crystallization to take place, a solution must be super saturated. So solution must be super saturated. And what is the super saturation? Super saturation is a term which refers to state, a state in which the liquid, okay, so means the liquid or solid contains more dissolved solids. Okay. It is a state where a liquid contains more dissolved solids than can ordinarily can be accommodated at particular temperature at the same temperature. So supersaturation at a particular temperature, one single liquid can be contain more dissolved solids. Okay. And the crystallization process consists of three major events. First, nucleation, uh, second, crystal growth, and supersaturation. So these three steps are involved in the crystallization. So first we will discuss about the nucleation. What is the nucleation? Nucleation is the step where the solute of molecule is dispersed in solvent and they will start to gather into the clusters on the nanometer scale. Means it is a technique where solute or new molecule will are dispersed in a solvent and they will start to gather to the cluster on a nanometer scale. The cluster reach a critical size in order to become stable nuclei. Okay? They want to become a stable nuclei, and this is detected by the operation condition such as the temperature, supersaturation, etc. So total nucleation is the sum effect of two categories of the nucleation, primary and secondary. If we talk about the nucleation, there are two nucleation, first primary and secondary, and total nucleation is the sum of the two nucleation, primary and secondary nucleation. So both nucleation are conducted. First, we discuss about the primary nucleation. Primary nucleation is the initial formation of crystals. It is the initial formation of crystal where there are not any other crystals which are present. It is means the initial formation of crystal where no crystals are there. If there are some crystals which are present in the system, they do not have any influence on the process. So it is primary step of the crystal formation. And the primary nucleation is occur in two conditions. First, homogeneous nucleation and heterogeneous nucleation. Two stages, homogeneous and heterogeneous nucleation. Homogeneous means same type of crystals are formed, and heterogeneous means some other type, some variation may be found. Next is secondary nucleation. Secondary nucleation is the formation of nuclei. Formation of nuclei, which is attributable to the influence of the existing microscopic crystals in the magma. First type of non-secondary crystallization is attributable to fluid shear. Means the fluid of the material is shear, and the other is due to the collision between the already existed crystals, which either form a solid surface of the crystal or they form a crystal themselves. So two things are happening in the secondary nucleation. Nucleation growth, second number. First was the nucleation, and the second is the crystal growth. Once the first small crystals, the nucleus forms, okay, it acts as a convergence point for the molecules of solute, and it's just adjacent to the crystal so that the increase its own dimension. If the crystals have been formed, then the crystals which have been formed, they will start to prepare the growth. One crystal layer, one second crystal layer, one third crystal layer, fourth crystal layer. So they will start to make some growth, some layers, which is known as the crystal growth. And growth rate is influenced by several physical factors such as the surface tension of the solute, or pressure, temperature. We can apply some pressure, we can uh, provide some temperature, low temperature will lead to the high nucleation, high crystal formation, and similarly some velocity, crystal velocity is also important. Which factors are important? First, surface tension, pressure, temperature, relative crystal velocity. So these factors depend on the crystal growth. Next, the supersaturation of the solution. So supersaturation is conducted in three forms: heating the solution, cooling the solution, and salting out. Heating the solution, cooling the solution. First, we can heat the solution. Supersaturation means and the molecule is super. The concentration of the crystals are increased, which is conducted by three things. We can heat the solution. After heating, we can cool the solution, and when the sample have been cooled, then the cool samples need to be removed from the salts. The salts must be removed from the cooled solution. To be cooled, then they can be prepared some supersaturation point. So in this lecture, I discussed all these things, which include the general introduction of the crystallization. What is the definition of the crystallization? I will repeat the definition of the crystallization. Crystallization is the process of the formation of crystals which precipitate from a solution. They are melt and they are deposited directly from a gas. And crystallization is also a chemical and solid liquid separation technique in which the mass transfer of solute from the liquid solution to a pure solid is achieved. Okay, so in this lecture, I discussed about the common introduction of the crystallization, what is the crystallization, and what is the use of the crystallization in different fields, and how crystallization is achieved. Okay, what are the crystals? How the crystals are being formed? Different techniques of the formation. What are the shapes of the crystals? Okay, different shapes. How the shapes are created. Okay, and what are the types of the crystallization? The first type is nucleation. Okay, and then the nucleation is also of two types: nucleation, nucleation, and the secondary. And the sum of the primary and secondary nucleation is known as the nucleation. Okay, the second type of crystallization is the crystal growth. If the nucleation is conducted after nucleation, when the crystals have been prepared, they will prepare their growth into the layer. one layer, two layer, three layer, four layer. The layering will be conducted in the crystals, which is known as the crystal growth. And after that, the last one is super saturation, which include three things: heating solution, cooling of the solution, and removal of the salts from the solution. So these three things are used for the super saturation. So I hope the students will better understand all these things. So in this lecture, I discussed about the some normal introduction about the uh, crystallization. And so what are the questions? Explain crystallization and explain the types of the crystallization. Explain nucleation, explain growth of crystals, explain supersaturation. So these questions can be asked. So my lecture is over here. In the next video, I will discuss some other things. So thank you very much.